But that's not something that the typical homeowner thinks about. They're imagining carpet protector a little different as far as its advantages of what the professional cleaner knows is harming the carpet. They're thinking about stains. When their kid drops the sippy cup full of Kool-Aid, or the Gatorade gets spilled over, the cup of coffee gets spilled, something that makes a very obvious stain in the carpet, they're concerned that that be easy to clean up. So those are three expectations that all should come from a good quality carpet protector. So how do they accomplish that? The key is reducing surface tension. Now, when we're talking about a liquid, it's generally called surface tension. The same thing when we're talking about a solid is surface energy. So, in practical terms, those two words are interchangeable, but generally when we talk about water or liquid, it's surface tension. When we talk about the fiber itself, then we're talking about surface energy. It's the same function as the Teflon skillet to make the eggs slide off easy when you're cooking them. Makes the dry soil slide off the carpet easily, or makes the water bead up on your car when you've waxed it and put the polish on it. Because of the difference in surface tension, that water doesn't spread out across the surface, but it beads up. To put some actual numbers to it, these represent the surface tension. It's in dynes per square centimeter for those of you that like to know all the details. But what really matters is if the liquid has a lower number than the surface tension, basically you're going to win out. That is, the surface is going to get wet. It's going to spread out. So cotton fabric, say on upholstery, has got a surface energy of 72. Any liquid that has a lower number is going to soak into the cotton quickly, going to spread out across that surface. There's the numbers for some carpet fibers, the nylon, polyester, olefin. Well, water is going to quickly be absorbed into cotton, not so quickly into some of the other fibers. But if we talk about oils like mineral oil, that's going to absorb into some of those other fibers. If we talked about alcohol, alcohol has an even lower surface tension. It's going to quickly soak in. But with protector, we bring the surface energy of that fiber down to around 15 if it's a fluorochemical type protector. Now, our water and our mineral oil are not going to soak into the fiber quickly because the protector has lowered the surface tension. The lower number wins. When we talk about wetting the surface, I wanted to do a demo, but not all my stuff got here. If you've been in a carpet class, a CCT class, you've probably seen this demo done anyway. Take a piece of cardboard, brown paper, put some water on it, and it sits there. Put a little drop of detergent on it. The detergent has lowered the surface tension. It's going to quickly be absorbed into that piece of paper or cardboard or whatever. It's a difference of surface tension. So when we talk about wetting the surface, instead of a liquid beading up like it did on that car wax in the first couple of slides there, it's going to spread out and cover the whole surface. It's going to soak in. Doesn't mean that something can never soak in if there's protector there, but it does mean that the protector gives some time before it soaks in. It's not going to be absorbed as deeply into the fiber. It gives some chance to clean it up. So if Mrs. Homeowner knows something spilled, gets the towel, wipes it up pretty quickly, it's going to be easy to absorb. That doesn't always happen. They don't know about spills, they don't clean them up. For some reason, something sits on the carpet for a while, it's not immediately blotted up. It's going to soak in. Hopefully it's still going to be easier to clean because protector's been applied to it. Well, is beading an important feature? Jim's going to talk about this a little bit more in detail. And a lot of the tests of protector involve beading. If we go to the ASTM tests that were developed, they take drops of liquid from a pipette and place them on the carpet from just above the surface of the fiber, and they bead up and the protector is applied. That's a great marketing picture. That's a great demo for your customer, but it's not a real life situation because very few people spill things from just above the surface of the carpet. They knock something off the table, they drop it from their hand, it's 2 or 3 or 4 feet above the surface. We've tried to do some testing that replicates more real life experience. It won't always bead up like that. Jim will talk about that feature later though. It does help it if you're wiping things up right away, but think of it as mostly a marketing feature. If we drop something on fabric, the fabric is basically a flat two-dimensional material. Things can bead up on it pretty easy. If we're dropping something from a height onto carpet, it's kind of like dropping it onto spikes. That liquid's going to hit all those third-dimensional pieces of carpet fiber, and the surface tension is broken. We're going to lose that battle of having enough surface tension to keep the liquids out. Most cleaners probably think fluorochemicals when they think of protector. There's a lot of other kinds of protectors out there though. When I first had to bid on a large commercial account, the specs for the account said protector would be applied. On a 48,000 square foot job, my competitor bid this at 0.95 cents per square foot. Now, I couldn't even buy a protector for less than 4 cents a square foot. He was going to buy it and apply it for less than a penny a square foot. Well, that's because the protector was not specified what it was. He was using colloidal silica, kind of clean sand. The idea is this clean polished sand will fill all the abraded spots in the carpet. Then there's not as many places for dirty dirt to fill in. And you can buy that for about 1/3 cent per square foot if you need to compete. There's silicone protectors. Carpet manufacturers don't care for them. They have issues with yellowing with age, for one thing. Another factor is although they provide good protection against water, not so much against oil. So if you wanted to protect your clothing when you're out in the rain, your camping gear so your tent doesn't leak when it rains, silicone might be a good protector for you. But if your carpet's going to get oil on it, maybe not so much. We've also seen some green products recently. Well, protectors are based on polymers. Polymers are long-chain molecules. One of the requirements to be green is that they biodegrade, that they decompose in a reasonable period of time. not a quality you really want in a protector if you want it to last. You don't want it decomposing on you. But there are polymers that will break down quicker. They provide a reasonable degree of protection, but don't expect them to last as long as a fluorochemical. And then the products that most of us use are fluoroprotectors. We're also going to be talking about a comparison between solvent-carried and water-carried products. What are the advantages of a solvent carrier? Well, it has good spread and penetration. It has higher coverage rates because it spreads out easier. Depending on the particular solvent used, it may dry quite a bit quicker. Do this anyway and save my voice. On the negative side, with the solvents, you're going to be concerned about health and safety issues. Is it harmful to the environment? Is it harmful to breathe? What's the flash point on it? Can it catch fire? The water carrier is going to have a lower cost, less regulations, fewer concerns about health and safety. Jim, can I get you to talk for just a minute while I get my voice back?
This reminds me of I was involved in an online training program, a webinar, and I was disconnected. The group couldn't hear me. You know who pitched in when they couldn't hear me? Take that, Scott. All right. So, which fibers have the greatest need for protection? So some questions that Scott's asking here. I think that his opening should be things that are more absorbent, certainly would. Do they accept protectors equally? Common sense is no. More absorbent ones will accept it differently. Do all fibers get the same benefit from protection? Once again, the common sense answer is what gets the most benefit has a lot to do with its needs. So there you go. All of them can benefit from it. More absorbent ones do accept more protector. Well, this has always been controversial. Is it worth anything to protect olefin? Well, the fact is, protector will adhere better to a braided olefin, and it does improve its oil resistance. So oil resistance is an issue. Thank you. That you should address. Okay. Are you ready, or shall I continue? Okay. You tap me on the shoulder when you're ready, sir. All right. So address oil resistance. Now we have another test that was done here by professional testing labs, which will be my part. But this is some good examples of the difference. Just if your customer vacuums a carpet, if being a big if, between cleanings, they certainly will get marked improvements of the quality of appearance and use of their carpet as they go, if they have a good protector. There's one showing treated and untreated. So that's saying all things being equal. You've cleaned the carpet, you've not left a lot of residue, you've not done anything bad in your cleaning. But your customer's normal maintenance activities, if they vacuum, that carpet that's protected will look cleaner longer.
Jim?
Oh,
What's that, is that delta E at the bottom?
I'll let Scott take over. This is his turn. I was just a stand-in.
See you later.
The delta represents the change in something, in this case the change in light reflectance of before or after. So on the control side, which was not treated with protector, these gray goods, there was a change of 17.29 on a scale of 1 to 50. There was a change in light reflectance of 10.5 on the treated side. In other words, it's not still like new. There was still some change because some of that soil adhered to it, but it was much less of a change. Less of the soil was detracting from the appearance.
How do they create a baseline for something like that, and how do you grade that for that change? I'm not quite understanding when you say that. Those numbers sound great, but relative to what?
Okay, these are gray goods samples, which is actually from Shaw. It's an unprinted, undyed, unprotected piece of carpet. They'll get a measurement of the light reflection from that carpet. Then there'll be a control piece that is untreated, one that is treated. these essentially are put in a drum with a certain amount of soil and some ball bearings for weight, and as that drum revolves, the weight of the ball bearings bangs that soil down into the carpet. It's a way of kind of simulating the action of foot traffic. So after 4 hours' time, you have the equivalent of about 1 month, 30 days worth of feet tracking soil onto that carpet. Then it's vacuumed.
What's the measurement of reflection? What is luminous? What do they use for the measurement of reflection?
Well, it's an arbitrary scale. It's just on a, and I imagine different laboratories might even have different scales that they use. This one's from professional testing laboratories, but it's not in any special unit. It's just where it fits on their scale.
Would the sample have been dipped in the protector, or would it have been sprayed on like we sprayed on?
This one was a DuPont test, and DuPont did not reveal all the details of how much was sprayed on it. You'll be able to see the test in Jim's section where he can give you the details. I know that this was sprayed on, but at what coverage rate, that kind of thing, I don't know. But it's unprotected versus DuPont Teflon. Another thing that some protectors do is protect against acid dyes. This little diagram will try to help explain it. If we have, for example, a carpet with dye sites, this would be nylon or wool. Those dye sites have a certain electrical charge to them that the dyes are attracted to. But especially if the color of the carpet is not a very deep, dark, rich color, not all the dye sites are filled with dye. So you've still got some electrically charged places on the carpet top. If the food coloring comes in that has the positive charge, this would be your Kool-Aid or your Gatorade or most any of the FDA type dyes that we put in food and beverages, they can be attracted then. If we put the acid dye resistor on that has the positive charge, it fills a lot of those dye sites. Therefore, the carpet changes from having a net negative charge to a net positive charge. Now if food coloring spills there, well, opposites repel each other, so the food coloring is repelled. It might physically be there by gravity, but it's not electrically connected to the carpet. It's just laying on the surface, or maybe it's down in the backing or wherever. It doesn't make it disappear, but it doesn't bind to that dye site, and it's going to be easier to clean out. Here's an example where the center area was treated with an acid dye resistor. The control spot on one side, the untreated side on the right. Both were put in the red dye number 40 that they use with Kool-Aid and such things. It was attracted to the dye sites that were available to it, but where the dye sites were protected by the acid dye resistor, the Kool-Aid wouldn't stay. Here's in an actual hotel lobby at another hotel. The part of the inside of the room was treated, the outside of the room in the area to the guest services. It was a room similar to this, just like the door at the end of the curtain where the people that take care of the building go in and out. The public area was treated, but not the private area. You can see the difference that made following the cleaning. Some guidelines when you're applying protector: be aware of not using too much pressure or too small a tip. You want the protector to go on the carpet. You don't want it to aerosolize and be small droplets drifting around in the air. It doesn't do any good on the air, and it could end up being inhaled and damage to somebody. So, By way of review, the protectors reduce the surface energy, keep liquids like water and oil from penetrating, should also resist dry soil. Some protectors protect against food coloring, and essentially it should make the carpet stay cleaner longer and be easier to clean. But it doesn't keep the carpet like new. Carpet and fabric can both benefit from protectors. The main way that protectors lose their value is simply they're being abraded or worn off. Not so much cleaned off as it just is by foot traffic and normal use. So you want to put it on and refresh the level of protection regularly. Jim, I'm going to let you talk for a while.
Okay, thank you.
Give me a moment to change the slide to the next slide. One of the things that I do want to ask you to do, some of what I'm going to show you is going to be create questions. And so that we have time to get through all the slides, I'd appreciate if we could hold the questions until I've concluded. So if you see something that's really going to burn you up, make a note of it, write it down or something, but be patient with me till I'm done. And by the way, I have a soft voice. If I get too far from the microphone, somebody wave at me and I'll get back to you. I'll get closer. The idea of having some independent tests done on a protector was important to the parts of this organization, of this show from Mikey's board. This has been discussed for a while that some individuals wanted to see independent testing of the protector. Not, for example, DuPont had a test they did with their product. Well, that's good and they have some good testing. What would happen if these protectors were tested by an independent laboratory? So the presentation that I'm going to share with you is the results of some things that were done by an independent laboratory. Some of the results are inconsistent, some of them are perhaps even controversial. There's one point where I'm going to read a statement from one of the people involved in one of the products involved in the test to be fair to that manufacturer. But again, that's why I think we'll create some questions. If there's time to answer them at the end, I'll answer them from the podium. Otherwise, I will be present at the outside. You can talk to me at that time if you'd like. In any event, the plan was to have this independent test done. The soiling test was done in professional testing laboratories, which is used by many of the carpet inspectors and is respected by the carpet manufacturing industry. The spill testing was following just some common sense guidelines that I'll discuss. See, here's a challenge. It's hard to really see a true test of your protector because you don't protect unprotected carpet for the most part. You're protecting damaged carpet. Since 1986-87, most of the nylon carpet installed in your customers' homes has had a fluorochemical and an acid dye resistor applied to it. Depending on the care they've given that carpet, who's been cleaning it, and how it's been maintained, there's some degree of protector that you reapply and repair. So it's hard to demonstrate, it's hard to ascertain what's really occurring because each job becomes different. Every carpet you clean, hard as it is for some of us to appreciate or admit this, retains some soil when we're done. We never get all the dirt out. So that's something that can impede your protector. Sadly, all carpets retain some detergent. Now, a lot of us take pride in doing rinsing of carpet, using special rinsing agents, soft water, powered water. We have all sorts of ways that we're trying to rinse the carpet, and that's commendable. But there is no system that takes all the detergent we put in the carpet out of the carpet either. That's an impediment to how a protector works. Every carpet you clean has had a different experience. Some have been very experienced. But the fact is, things have happened to that carpet that will be create inconsistency. And the fact is, we're not cleaning all nylon. There's a lot more polyester out there today. We clean olefin and we clean some wool. So even the things that we share here today can only begin to give us a baseline of seeing how things perform. So there was an attempt to establish a consistent test sample, Using an independent lab that seems to know what they're doing was a good start. It's kind of hard to just spray the stuff on and walk back and forth and know we've done it right. The spill tests were using pre-measured fluids at specific heights. Scott talked about that. We did the drip above the carpet, then we did some of the drops from 3 feet because you'll see some different results when that happens. Tried gray goods carpet. Now that means this is carpet that's had no factory protector or dye as a baseline. That's not what you clean. But the idea was to get something that had no soil, no residue, that we weren't cheating by using a protector they put on first. Because everything you clean, or most everything you clean, has a mill-applied protector. Now this part's controversial. The tests done here have 4 times the recommended amount of protector put on. Reason why, we were protecting unprotected carpet. The thought was to try to get as close as we could to having factory protector on that was broke down, beat down, than what you put on top of it. Because we didn't want to take carpet that had factory protector and put protector on it. That'd look great. And yet, we couldn't get something that was worn to any particular extent that would be consistent. So, with an understanding that this is the best simulation possible. There was a question earlier about, is this stuff dipped or sprayed? That's a tough call because when you take small samples, what kind of sprayer sprays 1/8 of an ounce out of a sprayer? You know how they kind of run out at about 4 ounces at the bottom? So there's issues on this. This was spray applied, but that was a difficult challenge to get around. So it's the best we could guess, and I'm using the word guess with a capital G, of what you'll see.